After having learned amplitude modulation in the previous sessions, from this session onwards, we'll be studying what is frequency modulation. Frequency and phase modulation. So how do we define frequency modulation? Or what is frequency modulation? Frequency modulation is a system in which the amplitude of the modulated carrier is kept constant while its frequency and rate of change are varied by the modulating signal. In the previous sessions, while studying amplitude modulation, we learned that in amplitude modulation, we are changing the amplitude of the carrier signal with respect to the message signal. In frequency modulation, we are changing the frequency of the carrier signal with respect to the message signal. All of you are able to understand? Basically, we are transmitting a message signal and we want this message signal to be received at the other end, reconstructed, demodulated and used for reception. First method, the message signal is there. The amplitude of the signal you are varying according to the message signal. You are demodulating it and getting the original signal which was transmitted. That is very simple and that was the thing that was first developed and the easiest method of modulating a signal. When it comes to the next phase, we started improving our conditions. Instead of varying the amplitude of the carrier signal, we are processing with the frequency of the carrier signal that gets changed with respect to the message signal. Is that clear for all of you? All of you understood what is frequency modulation? FM? Yes. Similarly, we have phase modulation also. When I write the mathematical expression for a equation, let us say A sine 2 omega t plus phi. This is the basic equation of any signal, right? Let us say that we have a signal V and the equation for the signal is A sine omega t plus phi. A is the amplitude. When we change amplitude, it is called as amplitude modulation. Omega is frequency. When you change the frequency, it is called as frequency modulation. And phi is the phase. When you change the phase of a signal, you call it as phase modulation or angle modulation. These are the three important types of analog modulation that is used for communication. So let us understand it slightly better. This is the message signal and you have a carrier signal that varies with the amplitude, and here you have here you have a signal whose frequency changes with the message signal. When amplitude changes, you can understand that it moves like this. When frequency changes, you are having gaps in between. Do you know how a sound signal travels? A sound wave travels with compression and rarefaction. The air nearby your mouth while you speak gets compressed and rarefaction, it gets expanded and compressed. And a sound wave travels like that. Similarly, when you modulate a signal using frequency modulation, the frequency of the carrier signal that is shown here changes with respect to the message signal. Now let us consider the equation for frequency modulation. M of t is equal to Am cos 2 pi Fm t. In this case, the instantaneous frequency of the modulated wave, that is frequency at a particular time t, is given by Fc plus Kf Am cos 2 pi Fm t. Now this is the message or the modulating signal M of t, and the instantaneous frequency at one particular point of time, which depends upon the modulating signal, is given by the carrier frequency plus kf am cos 2 pi fm t. Fc is equal to, that is Fi of t is equal to Fc plus delta f cos 2 pi fm t. This term kfam is called as frequency deviation. Delta f is the change in frequency or frequency deviation. It is defined by kfam. What is kf? We'll see in the next slide. Am is the amplitude of the modulating signal. Define frequency deviation is a very common question in your question papers. You may need to answer that. So mathematically, we'll define a term called as beta, which is the modulation index for the frequency modulated wave. Beta is defined as the maximum frequency deviation by the frequency of the modulating signal. In amplitude modulation, modulation index was defined as the amplitude of the message signal by the amplitude of the carrier signal. Similarly, for frequency modulation, we will be defining beta, that is the maximum frequency deviation delta f by the modulating signal frequency, which is fm. And we'll be understanding a term called as bandwidth. Previously also I told you, I gave an introduction to bandwidth. Bandwidth of an FM signal is given by, bandwidth is an important resource factor, is a very important concept that you have to understand. In case you don't understand, you can ask me now, I'll give you explanation. Bandwidth of an FM signal is given by 2 times delta F plus FM. FM is the modulating signal frequency. This particular method of finding out bandwidth is known as Carson's rule. As such, Carson's rule was not mentioned previously anywhere, but you had a question in your question paper saying using Carson's rule, do this, do that. So in that case, I just mentioned about it. So If you are asked to define bandwidth of a frequency modulated signal, I hope you can do that. If you are asked to explain what is meant by frequency deviation, you can do that. If you are asked to find out how to find the modulation or modulating index of a frequency modulated wave, I believe you can do that. So let us continue with our derivation. Theta I of t be the angle of the modulated sinusoidal signal at a particular time t. It is assumed to be a function of the information bearing signal or a message signal. So let us consider theta I to be the angle of the modulated sinusoidal signal which is having the or which is carrying the information that is being transmitted from one point. So the resulting angle modulated wave is given by S of t is equal to AC cos theta I of t, where AC is the amplitude of the carrier signal. So this is an introduction to angle modulation. We are modulating the carrier signal's angle or the phase at a particular time t. So in an angle modulated signal, the output will be the amplitude AC, amplitude of the carrier signal cos theta I of t, where theta I is the phase or the angle of the modulating signal. So what is phase modulation? Phase modulation is defined as that form of angle modulation in which the instantaneous angle theta I of t is varied linearly with the message signal m of t. Varied linearly means as much as there is a change in the instantaneous angle, so much as there is a change in the phase. That means the graph between both these things are linear. Okay. Directly proportional. Now in this particular equation, we can see that 2 pi fc of t represents the angle of the unmodulated carrier with the constant phase 5c. This is set to E0 for the convenience in case of presentation. The constant Kp represents the phase sensitivity factor. So you may be asked to define what is meant by phase sensitivity. Okay, phase sensitivity factor of the modulator expressed in radians per volt on the assumption that m of t is the voltage waveform. The amount of change, like the modulation index, here we have phase sensitivity also, which means that the amount of change in phase. The phase modulated wave S of t is correspondingly described as, let us describe it in the time domain. S of t is the function of t, AC cos 2 pi fct plus kp m of t, where kp is the phase sensitivity. So, like what we have defined frequency, like phase modulation, we are going to write notes for frequency modulation for the sake of presenting into exams. Frequency modulation is one way or the other a type of angle modulation, because when frequency changes, phase also changes. The angle also changes. So here we are defining the instant frequency Fi of t, which also linearly varies with the message signal. Fi of t is equal to Fc, the carrier frequency, plus Kf m of t. Kf is a frequency sensitivity factor, which we have seen in the previous equation while deriving frequency deviation. or while defining, sorry, not deriving, while defining frequency deviation, we have seen this kf, right? So this kf is called as frequency sensitivity factor. Define what is frequency sensitivity factor. It's a form of modulation expressed in hertz per volt. Phase sensitivity was expressed in terms of radians per volt, and frequency sensitivity is expressed in terms of hertz per volt. On the assumption that M of C, so here that M of t is a voltage waveform, okay? So phi of t, the change in angle, is defined as 2 pi integral 0 to t phi I tau of d tau. This is equal to 2 pi fc 2 pi k f integral 0 to t m tau d tau. This second term accounts for the increase or decrease in instantaneous phase due to the change in the message signal m of t. Thus, the frequency modulated waveform is defined as S of t is equal to AC cos 2 pi fct plus 2 pi kf integral 0 to t m of tau d tau. Like we have written the output waveform for the amplitude modulated wave. Here we are writing the equation for the output of the frequency modulated wave. In that case, like we have two terms. One is 2 pi fct, the other one is about the message signal, that is 2 pi kf 0 to t m tau d tau, where kf stands for frequency selectivity or sensitivity factor. So thank you for listening. In the next class, we'll be dealing with a comparative statement of all kinds of modulation.